Hello, one and all, and welcome to a ramble with me, dearest, confusedest, chaoticest. We are rambling today about the department's paper 1 from May 2022. We're looking at question 9. Sketched below is the graph of f of x is equal to x cubed plus ax squared plus bx plus c. So this is a cubic function. The x-intercepts of f are at 3, 0 and m, where m lies on the negative x-axis. K 0 minus 3 is the y-intercept of f. M and n are turning points of f. So the first question asks us to show that the equation of f is given by the following. So what clues are we given here? We're told we have a y-intercept, so that gives us one equation. We have an x-intercept, so that gives us another equation. We also know that the other x-intercept is a turning point as well. That might be useful. So let's see, and we're trying to find 3 unknowns. So we're hoping for 3 equations to come out of these clues, Right, so let's see. So from K having the following coordinates, we are able to say that f of 0, man, my zeros are looking like 6s, is so weird. So f of 0 is equal to minus 3, pretty much, is what this point is telling us. So f of 0 is 0 cubed plus a times 0 squared plus b times 0 ish. I'm just realizing now that I don't think I did a lot of preparation getting this graph onto all the different pages, but I think I should delete them so that as I fill in information, I can just duplicate the graph for all the future questions. Oh my goodness, this is going to take 5 million years approximately. Askis, guys, askis. Diqolele uqolo. Okay, we are done. Anyway, so now also, can we just write a bit smaller, Miguel? Yo, goodness gracious me. Okay, so f of 0 is going to be equal to 0 cubed plus a times 0 squared plus b times 0 plus c. Okay, so this minus 3, right? First term disappears, second term disappears, this one disappears, all we're left with is c. Okay, so that's the first, what an underwhelming highlighter. That's our first solve. Okay, next up, I'm going to put in this x-intercept. So we know that point 3, 0 lies on f. So this was the first clue that we used. This is the second clue that we're going to use. Okay, so then we know that f of 3 is equal to 0. Right, so again we'll have a times, no, should we start with the x? Askis. So 3 to the 3 plus a times 3 squared plus b times 3 plus c, which we now know is minus 3. We know that that gives us 0. So that is 27 plus 9a plus 3b minus 3 is equal to 0. So that is 9a plus 3b. 27 minus 3 is 24. and we can divide through by 3. Okay, so that would end up being 3a plus b plus 8 is equal to 0. So that's an equation that we will just hold on to. Hopefully we can find another equation in terms of a and b, and then we can do some simultaneous equations vibes, maybe, who knows. Right, let's get another page in the mix. So the other thing that I said I'm going to try to use is the fact that the other x-intercept is also a turning point. I don't know. Let's see. So so I'm going to get the first derivative. I'm going to get the gradient function for this function. So our function is x cubed plus ax squared plus bx minus 3, our c that we found not too long ago, right? So therefore f prime will be 3x squared plus 2ax plus b. Okay, so I had an idea of where I wanted to go, but now I'm so lost, so confused, so downtrodden. I wanted to say, I'm gonna try to find where these two are equal, but that doesn't necessarily have to be only at the x-intercept. Like, that could happen in other places as well, who knows. And also, like, equating these two, it's not really giving promising. So another thing that I was thinking about was to say, well, okay, maybe let me try and solve for when this is equal to 0, because I know that that only happens in 2 places. It happens here, and maybe something about the solution will inspire me about the next step. So let's see. We know that at m, whose coordinates are something and 0, because it's an x-intercept, f prime of x will be equal to 0. So let's solve that literal equation and see what it gives us. So this is a quadratic. If I solve for x, quadratic says minus, yeah, it's always confusing when there's the same letters but they mean different things in the contexts, the different contexts. So this would be in the context of ax squared plus bx plus c is equal to 0. So in our case, this guy is this guy, okay, and this guy is this guy, and then finally this guy is this guy. Okay, right, so we have minus purple plus or minus purple minus 4 times green times red divided by 2 times green. Okay, so this is minus 2a plus or minus 4a squared minus 12b over 6. I'm just going to simplify this because I'm not really sure where to go next, so might as well just have fun in the waiting room. This is 2 times 3, well, which is pretty much what we had before we times it out. So this would be 2 times a squared minus 3b over 2 times 3. So we can factor out the common 2. So we'll be left with minus a plus or minus a squared minus 3b divided by 2 times 3. So now we can cancel these guys. So that is minus a plus or minus a squared minus 3b times 3. Well. What does that even mean? What does that mean to any of us? What does that mean to anybody? Nothing. Let's just look at this carefully again. So we have the x-intercepts of f are at 3, 0, and I don't know. The O is, well, this guy is going to be x minus 3 times x plus something times x plus something. Because this is just one, this x-intercept is like, it's eaten 2 x-intercepts into one. Why wouldn't it be x minus 3 times x minus 3 times something? Why can't that also be a thing? I don't know. Don't eat me. I don't know. I just have a feeling that it's because, like, if you move this slightly up, then you get 2 x-intercepts again. It just feels like this one is the one that is the double x-intercept. Pretty much like when you have a parabola, right? So that, I don't know. I'm not making sense, but anyway. K is the y-intercept of f. M and N are the turning points. Yeah, we don't really know anything about N. Yeah, I feel like this page is very questionable. The value of this page is very questionable. So let us just try again, try a different approach. So let us just say that the coordinates of M are M and 0, right? So then let's say maybe that my function f of x is equal to x minus 3 times x minus m squared, right? And like I said, the squared is very questionable, because why is it this one squared and not this one squared? I'm not sure yet. Let's cook, okay? Let's cook. So if I multiply that out, that's going to be x minus 3 x squared minus 2mx plus m squared. And if I multiply these two brackets out, so we're going to have, if I times x by everything, x cubed minus 2mx squared plus m squared x. And then if I times everything by minus 3, I get minus 3x squared minus 3mx plus, not plus, yeah, in fact this is meant to be a plus, this will be a minus 3m squared. Okay, so this is x cubed minus 2m plus 3 x squared plus m squared plus 3m x minus 3m squared. Okay, so that's another possible representation of f of x. So now, if we put the same information in, the same two clues that we got over here, right? So we know that k 0 minus 3 is on this curve. Okay, so f of 0 is equal to minus 3. So 0 cubed minus 2m plus 3, 0 squared plus m squared plus 3m x, well, x being 0, minus 3m squared is equal to minus 3. Okay, so that term disappears, that term disappears, that term disappears. All we are left with is minus 3m squared is equal to minus 3. So m squared is equal to 1. So m could be plus or minus 1. M is the x-coordinate of the x-intercept, and we know that that is on the negative side of the x-axis. So we are going to say it's in the wrong place. But m is negative, so therefore m must be equal to negative 1. And then we can check, maybe, well, okay, we've already used this information, so we can't use it to check. We use this information to construct our function, right? That's where it's showing up. So yeah, we can't really be secular like that and use it to check. So essentially what we're saying is that our equation is x minus 3 times x plus 1 squared. I'm not happy. I'm not completely happy with the bit of randomness. I do want to check. So let's just say, for example, maybe this deserves a new page. So let's say we have, and we'll make it nice, some other cubic function, x plus 2 squared times x plus 5 versus x plus 2 times x plus 5 squared. What I'm interested in is how different do these curves look. So let's start with g of x. Okay, so both of these are cubic functions that look like this because the x cubed term will be positive, will have a positive coefficient. And secondly, they are both going to have their x-intercepts at 2, well, minus 2 and 5-ish. No, yeah, actually, let's make this negative because I'm not in the mood for negative x-intercepts. Okay, so G will have its one x-intercept at 2 and its other x-intercept at 5. And H will be the same. Okay. Right, so now let's see where will the y-intercepts be. So g of 0 will be 0 minus 2 squared times 0 minus 5. So that's going to be 4 times minus 5, which is minus 20. And the y-intercept for h will be 0 minus 2 times 0 minus 5 squared. So that will be minus 2 times 25, so minus 50, so it will be a bit lower. Okay. Oops. Okay, yeah, maybe it can go. So we're going to be dealing with something like this. Let me move this guy here. And let's do a similar thing for, in fact, let's just get rid of all of this and copy that one. Okay, so like if this one's y-intercept is here, this one's y-intercept is a bit lower at minus 50. Okay, then let's see what's happening with the turning points. Yo, Name, I'm going to need to multiply these things out. Okay, let me just quickly do that here. So for g, x minus 2 squared times x minus 5, so that's going to be x squared minus 4x plus 4 times x minus 5. So let's start by timesing with the x. So that will be x cubed minus 4x squared plus 4x, and then let's times by the minus 5. So that will be minus 5x squared plus 20x minus 20. Okay, so then we have our like terms, some more like terms. Okay, so we end up with x cubed, and then minus 4x squared minus 5x squared is minus 9x squared, and then 4x plus 20x is 24x, and then minus 20. Okay, so that's our first one expanded. And then the next one is x minus 2 times x minus 5 squared. So that will be x minus 2 times x squared minus 5x minus 5x is minus 10x, and minus 5 times minus 5 is positive 25. So now, if we multiply all of that out, x cubed minus 10x squared plus 25x, then if I times by the minus 2, I have minus 2x squared plus 20x minus 50. So now, quadratic terms, and then linear terms. Okay, so if we add those together, we get x cubed minus 12x squared plus 45x and minus 50. Okay, right. So now for our turning points, we're going to get the first derivatives. Okay, so for g prime will be 3x squared minus 18x plus 24, which means that the turning points occur 3x, yeah, I'm sure gonna need another page, I keep squishing. that is x squared minus 6x plus 8 is equal to 0, which is the same as x minus 4, x minus 2. So x is either equal to 4 or x is equal to 2, right? So that's going to be a curve that looks like that, right, where this is the 4 and the something else. Okay, right, and then this one, this other one, the h prime is going to be 3x squared minus 24x plus 45, right? And then the turning points will occur over here. Okay, divide through by 3. Okay, so then we have x minus 3 times x minus 5. So x is equal to 3 or x is equal to 5. So that would be a situation where we have the what's happening here now? What just happened? What just happened? I don't know what just happened. What just happened, guys? Did anyone see what just happened? Okay, so we are turning at 3 and at 5. So it would be something like this. Turn at 3 and then come back and turn at 5. Oh, not great, but something like that. So this kind of does agree with my little theory that wherever the squaring is happening, that's where you get the turning point that also doubles up as an x-intercept. Because here, when we're squaring the 2, that's where we get the turning point / x-intercept. And when we square the x minus 5 bracket, you know, at the 5 is where we get the turning point and x-intercept. So that kind of confirms the intuition. Okay, maybe confirm is a very strong word for it. But if someone can explain very nicely to us why this is, I'm also going to give it a think. But yeah, that seems to have worked for us. The fact that the turning point and the x-intercept are occurring here at m0 allows us to write our function as x minus 3, because the other x-intercept is happening at 3. Okay, allows us to write the function as x minus 3 times x minus m squared. We know that because that's where the turning point and the x-intercept occur, the squaring is on this bracket, not on this one. And so we go from having a function that has 3 unknowns and therefore us needing 3. I mean, in a way, we do still use 3 pieces of information to find the unknowns, but we go from solving equations in terms of a, b, and c to just solving it in terms of m. Right. And in order to do that, so the one piece of information gave us this equation. 2 pieces of information. We get this part from the x-intercept and this part from the x-intercept / turning point, and then we're able to use our third point to figure out the value of m, which we find to be plus or minus 1. But because we know that m is a negative number, right, because m is the x coordinate of this guy, which we are told is on the negative side of the x-axis, then we know that m has to be -1. So f of x is equal to this. And so, you know, we need to show that that is the same as that. So we're going to expand. Okay, so we have x minus 3 times x plus 1. Well, let's summa square the x plus 1. So that will be x plus 2x plus 1. Well, x squared, sorry. Then we times the x through. So that will be x cubed plus 2x squared plus x and then minus 3x squared minus 6x minus 3. And so that becomes x cubed minus x squared minus 5x minus 3, which is indeed what we were given. X cubed minus x squared minus 5x minus 3. Very curious to see how the memo went about this. But yeah, also an interesting finding, something to hold on to for future questions, that if you do have a situation like this, you know then that your equation is going to look like x minus whatever this number is squared times x minus whatever this number is. Okay, right, so we'll just quickly move along from our other attempt that we had to desert. Right. Okay, so here we are next. Right, and we have now discovered that our m is minus 1. Okay, and we also know that our function is x squared minus something else, this guy. Okay, right, next question. Says, calculate the coordinates of n, the other turning point. Okay, so we can do that using calculus. So we know that f prime will be 3x squared minus 2x minus 5. So we're going to look for the place where our gradient is 0. Okay, quadratic equation, we can use quadratic formula. We can use factorizing maybe, hopefully. We do already know that one of the factors is x plus 1 because that's our first turning point. So that helps us a bit. So that means that this guy has to be 3x and this one has to be minus 5. Why? Because x times 3x will give me this term and 1 times minus 5 will give me this term. So let's just see if we get the middle term. Minus 5x plus 3x does indeed give me minus 2x. So x is either equal to minus 1 or 3x is equal to 5, meaning that x is equal to 5 over 3. Right, so therefore the x coordinate of n is equal to 5 over 3 because the minus 1 belongs to m. So then to find the y coordinate of n, we calculate the value of the function when x is equal to 5 over 3. So yo. Minus 256 over 27. Ugh, what a weird number. My goodness. Okay, so this will be 5/3 and minus 256 over 27. Okay, right. On to the next. So the next question says, for which values of x will f of x be smaller than 0? So these are the parts of the graph that we are concerned with. Okay. Right. Because from this x onwards, we just get positive values of f of x. So only for these x values do we get negative values of f. Right? So we could say when x is smaller than 3. Right? However, there is this place here where f of x is equal to 0. And we're not looking for places where f of x is equal to 0. We're looking for places where it's strictly smaller than 0. So we are saying if x is smaller than 3 and x is not equal to -1, then f of x gives us negative values, strictly negative values. A way that you can write that as well in interval notation is you can say, okay, anything from negative infinity, and we never include negative infinity, up until -1, not including -1, because when x is -1, f produces 0. Then from -1 we can continue on our merry way again, up until 3, but we don't include 3 for the same reason. F of 3 is equal to 0 exactly. It's not smaller than 0. So that would be our answer there. Next. Okay, the next question says, okay, first I just need to erase this stuff. The next question says, for which values of x will f be increasing? Okay, so that's where it has a positive gradient. So positive, 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 turning point, now we become negative, 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 turning point, now we become positive infinitely. So these are the parts of the graphs that, parts of the graph that we are concerned with. That piece over there and that piece over there. So we're asking ourselves which x values produce this portion and this portion. So for this portion, it's all the x values before -1, right? They are the ones that create this part of the graph. So it will be x is something from negative infinity up until -1. Okay, we'll think about the brackets in a moment. And then the next piece is from this point over here, the turning point, 5/3, until positive infinity. We don't have to think hard about brackets with infinity because they're never included. Infinity is never included. So now the question is, okay, when x is equal to -1, is f increasing or decreasing? So over here, because it is at a turning point, the tangent, the gradient here is 0. It's neither increasing nor decreasing. So we are not going to include -1. And for a similar reason, we don't include 5/3. This is a turning point. The graph is neither increasing nor decreasing over here. So we can't include 5/3. I think when you get to varsity, they begin to distinguish between a graph simply increasing and strictly increasing. So when it's strictly increasing, then we really don't include the turning points. But if you just say increasing, you can include the turning points. But I think in high school, increasing means exclude the turning points. I don't know. Anyway, so that's how you could write it. In inequality notation, you would say that x must be smaller than -1 or x must be greater than 5/3. Those are the x's that create these portions of the graph where the curve is increasing, where the function is increasing. Okay, next one. Yeah, when am I? Come on, diagram. What's going on? Okay, let's wrap out the old stuff. Oh my gosh, what is happening? Okay, so the next question says, for which values of x, will f be concave up? So this is this part roughly. Okay, so that will be from the point of inflection onwards. Okay, and point of inflection you can find in one of two ways. You can either use the second derivative, or you can use the fact that it will be halfway between the x value will be halfway between this and this. So you can just find the average of these two numbers, and that will give you the x coordinate of the point of inflection. But here, for the sake of calculus, let us use the second derivative to find the point of inflection. So I've lost my first derivative, not really in the mood to look for it, so I'm just going to do it again. So f prime will be 3x squared minus 2x minus 5. So then f double prime will be 6x minus 2. And so the point of inflection occurs when f double prime is equal to 0. So we are solving the equation 6x minus 2 is equal to 0, 6x is equal to 2, so x is equal to 2 over 6, which is a third. So the point of inflection occurs at 1 over 3 and some y coordinate. Don't really need the y coordinate, all we care about is the x coordinate, because now we know that before x is equal to a third, our graph is concave down, and after x is equal to a third, our graph becomes concave up. So it is concave up when x is greater than a third. And if you like to write in interval notation, that is a third not included upwards. And I think we don't include it for pretty much the same reasons like with the increasing and decreasing thing. At the point of inflection, the graph is neither concave up nor concave down. It's switching from one to the other. So it's only after a third that it becomes concave up. According to me, myself, and I, and my feelings. My feelings are my truth. Oh, guys, my goodness gracious me. The world that we live in is so entertaining. Okay, right. Last question, I think. My word, it's been a marathon. And that was my husband earlier that came in to ask if I want to eat. And I'm like, my goodness, I need to eat. I need to eat. I am so hungry. And yet at the same time, I still want to push and somewhere finish this video. Not this video, this series, because I think I just have 2 more videos to do after this. Anyway, we'll see. Determine the maximum vertical distance between the graphs of f and f prime in the interval -1 to 0, from here to here. Okay, so let's sketch f prime real quick. Again, I have lost it. I'm not interested in finding it, so I'm just going to derive again. So this will be 3x squared minus 2x minus 5. Okay, so what does this parabola look like? We don't really need to sketch it, but just for the sake of us knowing, we know that one of the factors is x plus 1, and then the other one ended up being 3x minus 5, right? Right, because yes, 3 times 5/3 is 5, minus 5 is 0. Yes, these were the true x-intercepts of our f prime. That's how we found these 20 points. Anyway, so our parabola is going to be happy because of the positive coefficient there, and its x-intercepts are here and here. So maybe let's do it in a different color, and also maybe not such a chatarach color. So maybe something like this, you know. Okay, and we are only interested in this, in the graphs between -1 and 0. So I'm even just gonna erase the parts of the parabola that I don't care about. And I'm erasing other information in the process, my goodness. Well, I don't know, we don't even really need that at this point in our lives. I'll put it back just now, don't worry. Yo. Okay, right, so we want to find the maximum vertical distance. So, you know, maybe, you know, it's giving maybe here by my own estimations, my own visual estimations. No, that doesn't look right. Anyway, so fine, the distance between these two graphs, and we can see that the parabola is underneath. So I'm going to say this guy minus this guy. Otherwise, if I said this one minus this one, then it's going to be a negative number, you know. So then we wouldn't be thinking about the biggest number. We would have to think about the smallest number, because negatives just work that way, you know. You want, I don't know if I'm making sense. So maybe I'm belaboring a point that is a moot point. Anyway, just choose the function that is on top. Right, so we're going to say, okay, f of x minus f prime x. You start with the function that's on top, so that your distance is a positive number, not a negative number. Then the calculation is more intuitive. So that will be x cubed minus x squared minus 5x minus 3 minus 3x squared minus 2x minus 5. So that is x cubed minus 4x squared minus 5x plus 2x, which is minus 3x, minus 3 plus 5. Right, so that is the function for the distance between these two graphs at any given x. You can work out the distance, the vertical distance between them, by plonking the x in here. So we want to figure out, when is this at its biggest in this interval, when x is between -1 and 0. So let's see. As a first stab, I'm going to find the first derivative of the distance, which is 3x squared minus 8x minus 3. And I'm going to try and figure out, when is this equal to 0? What are the local and the local minimum and maximum? So that is a quadratic equation again. Gonna try to factorize. So we'll start with 3x and x here, and then we could either have 1 and 3 or 3 and 1. Let's see. 3x times 3 is 9x. X times 1 is 1x. So we could have negative 9x plus 1x, and that would work. So that looks promising. Okay, so we are saying we're going to have 3x times negative 3 and x times positive 1. That does work. 3x squared minus 9x plus 1x minus 3. Good. So x is then either equal to -1 over 3 or x is equal to 3. And because this is a cubic with a positive coefficient for x cubed, we know that it's like this. So that means that this over here, when x is equal to -1/3, is a local maximum, and when x is equal to 3, we have a local minimum. Right, and we'll notice that this minus a third is between -1 and 0. So the local maximum is indeed the maximum distance when x is between -1 and 0. So local max. So therefore, when x is equal to minus a third, d is is at its highest in the interval -1 to 0. Right, and so the question is, what is that distance? So we're going to work it out. So d, when x is equal to minus a third, is going to be, yeah, you need to be copied and pasted, my friend. Okay, calculator, now's your time to shine. Wow, 14/27. My goodness, that is surprisingly small. Worryingly small, if I'm to be completely honest. But yeah, the numbers have numbered. Who am I? Who are me? Who are me? Alright, so that would be the maximum distance between these two graphs in that interval. 14/27. Oh, that looks so dodgy. I'm going to be so heartbroken if I'm wrong. Anyway, let's see what the memo has to say about our endeavors, and if it can shed light on that first question, because wow, that was really an interesting one. Where are we? Question 9. So they also just start out by saying f of x is equal to s plus t squared times x minus 3. No explanation, nothing. I don't know, guys. Is this something you learn now in your syllabus? Maybe it's just something I haven't. Hey, guys, I'm too old, potentially. But yes, so they go about finding our little m the way that we did, and yeah, we agree. Except they didn't go through the whole schlep of multiplying it out. So you could have just kept it like this and subbed in your values. You know, that would have been more peaceful. So 0 minus 3 times 0 minus m squared is equal to minus 3, and then far cleaner to work with than what I ended up with. So especially because you just end up discarding so many of the terms because the x is 0. So tut. Next question. Calculate the coordinates of n. Oh yay, we do end up with the same dodgy numbers. Exciting. And we both approach it the same way. So we move. Next question, x must be smaller than 3 and x can't be equal to -1. We are in agreement. Okay. Next one, x must be smaller than -1 or x must be greater than 5/3. We are also in agreement. They say that you could include the boundary, so that thing that I was saying about increasing versus strictly increasing, basically they wouldn't penalize you if you included the turning points, right? And then for the concavity question, x must be greater than 1/3. We are also in agreement there. There they don't let you include the third, so please don't include the point of inflection. Right, and then for the last one, yeah, hey, my numbers did not number, guys. My numbers did not number. We are not in agreement. So the question is, what did I get wrong? +2. Did I not +2 there? At the end I did. So the x is -1/3 indeed. And then we say -1/3 cubed minus 4 times -1/3 squared minus... Oh, ish. Dummy! My bad. Calculator errors, and not even calculator error. I just wrote it wrong. Because, guys, don't squish. Don't squish. Don't force to squish. Yeah? Stop squishing. Because now you end up compromising what you're writing. Because you're squishing. Give yourself space. Okay. Evan, did I literally just write down the... Oh, okay. I did not write down the same thing. I was just going to confuse myself again. Okay, so the moral of the story is don't squish. Okay, so that was meant to be a -1/3. And then, yeah, that answer feels a bit better, honestly, to my system. Okay. So 68/27, we are in agreement. Perfection. Nice question. Lots of different things tested. And yeah, I hope you had a good time. I sure did. Catch you hopefully for the last 2 videos in the series. Sharp.